Hi, good day! Welcome to General Mathematics tutorial videos, and our lesson for today is functions and graphs. Now let us have a simple recall of your rectangular coordinate system. The rectangular coordinate system is composed of two intersecting number lines. We have the vertical line, which is represented by the y-axis, and then we have the horizontal line, which is represented by x-axis, and that is forming an ordered pairs of x and y. X represents your first coordinate, or we also called it abscissa, and we have the y, which is the second coordinate or y coordinate. And as you can see, we have here four regions. We have the quadrant 1, which represents positive x and positive y. For quadrant 2, we have negative x and positive y. And for quadrant 3, we have negative x and negative y. And for quadrant 4, we have positive x and negative y. Now let us define what is a function. A function is a set of ordered pairs, x and y, such that no two distinct members have the same first element. So when we talk about the first element, we are pertaining to the value of x. Now let's have a simple activity. We have here four sets of ordered pairs A, B, C, and D. So for the first set, A, we have negative 3 and negative 4, negative 2 and 5, negative 1 and 5, we have 0 and 6. For the set B, we have negative 2 and 5, 0 and 5, 2 and 5, and we have 4 and 5. For set C, we have 0 and 3, 0 and 6, negative 2 and negative 4, negative 4 and negative 5. For our set D, we have 1, 0, 0, 1, negative 1 and 0, and we have 0, negative 1. Now what we are going to do is to list down all first and second coordinates of each set of ordered pairs and draw arrows showing the different pairings. So when we are talking about the first coordinates, we are dealing with the x, the values of x. And if we are talking about the second coordinates, we are dealing with the values of y. Then afterwards, we are going to plot the given set of ordered pairs. Now, moving on, let us create a diagram of each set. First, let us focus to set A. We have the first coordinates or the values of x as negative 3, negative 2, negative 1, and 0. For the second coordinates, we have negative 4, positive 5, and positive 6. Now, if you will notice, in set A, we use 5 as the second coordinates twice. In set of A, we have negative 2 and 5, negative 1 and 5. But we are going to write it in our diagram once. Now, let's proceed to set B. The first coordinates of set B are negative 2, 0, 2, and 4. And for the second coordinates under set B, if you will notice, all the second coordinates represent the value of 5. So we are going to write it down in the diagram once. And for the set C, we have the first coordinates 0, we have negative 2, and negative 4. In set C, we have 0 used twice, but we are going to write it down in the diagram once. Okay, and for the second coordinates of the set C, we have positive 3, positive 6, negative 4, and negative 5. And for our last set, D, we have the first coordinates 1, 0, and negative 1. In this set, we used uh, 0 twice as the x value, but then we are going to write it once. And for the second coordinates, we have 0, 1, and negative 1. Now, let us draw the arrows pointing to the values. And as you can see, we have here negative 3 and negative 4, negative 2 to positive 5, and then negative 1 to positive 5, and then 0 to 6. For B, we have negative 2 to 5, 0 to 5, 2 to 5, and 4 to 5. And then for C, we have 0, 3, 0, 6, negative 2 to negative 4, and negative 4 to negative 5. And for set D, we have 1, 0, 0, 1, negative 1 to 0, and then 0 to negative 1. Now, what we are going to do here is to determine which of these sets are functions by just merely looking at the diagram. Go back to the definition of function for us to be guided on what we are trying to look at in the diagram to determine whether it is a function or not. So it is stated that a function is a set of ordered pairs x and y, such that no two distinct members have the same first element. So we are going to focus on the first element or the values of x. So if there is no value being repeated, then we can say that the given set is a function. Again, we need to determine the set of first element. So there should be no two distinct members. So every value of our first elements are unique in order to determine that this is a function. Now let us go back to our diagram. Let us determine whether the given is a function or not function. Now look at set A. Is there any number being repeated in the set of our first element? So we have here negative 3, negative 2, negative 1, and 0. So each number is pointed to other numbers, but there is no repeated number, so we can consider this as a function. Now let's move on to set B. If you can see, we have here negative 2, 0, 2, and 4. Each has a unique value of x. There is no being repeated, so therefore we can consider this as a function. So again, our emphasis here is the values of your first element, not the second element. Okay, so just look at the first element or the values of your x. Now let us proceed to C. If you can see, you have here 0 and 3, 0, 6, negative 2 and negative 4, negative 4 to negative 5. If you are going to look at 0, it was being used twice. It was repeated to represent two different ordered pairs. So since it was used twice, we can consider this as not function because 0 was being repeated. Now let us proceed to our last diagram, which is set D. We have here 1, 0, 0 to 1, 0 to negative 1, and negative 1 to 0. Again, always look at the first element or the values of x. So we can also see in here that 0 used twice to represent two different ordered pairs, and therefore we can consider this as a not function. So with the use of our diagram and just merely looking at the first element of your set of ordered pairs, you can easily determine whether it is a function or not function. Now, I will show you another way to identify whether the given sets of ordered pairs represents a function or not. Now, let us use the same set of ordered pairs. Now, we are going to plot the given sets. For set A, we have -3, -4, -2, 5, -1, 5, 0, and 6. Then after plotting the points, just connect them. And for letter B, or set B, we have -2, 5, 0, 5, 2, 5, and 4, 5. And then connect the points. For set C, we have 0, 3, 0, 6, -2, -4, -4, and -5. Then after that, you connect the points. For set D, we have 1, 0, 0, 1, -1, 0, and 0, -1. And then after that, just connect all the points. And during our first diagram, we already identified which of the sets is a function and not function. So A is a function, B is a function, C is not function, and D is also not function. But how are we going to identify whether a given graph is function or not without doing any solving? So we are going to use the what we call vertical line test. A vertical line test is a graph wherein you are going to draw a straight line or vertical line drawn passing through the graph intersects the graph at exactly one point. So if the vertical line touches the graph at the vertical line at a single or only one point, therefore we can say that that is a function. Now let us go back to this illustration or graph and let us draw the vertical line test. For set A, just follow the green line. Okay, and for set B, as you can see, if we are going to draw a vertical line, the line will only touch our graph at a single point. But if you're going to look at C, okay, there are points that it will touch the line at a single point, but if it happens that it will touch 2 points in a single line, we can consider it as not function. Same true with our set D. If you can see, it touches 2 points in a single line, and that is already an indication that the given graph is not function. Now let's have some more activities. You determine whether the given graph or diagram represents a function or not function. So for this, we have 1, -1, 2 to -1, you have 3 to 1, and 4 to 1. So just look at the value of the first element. You have there 1, 2, and 3 until 4. And if you will notice, every element is unique. So there is no repeated value. And so we can consider this as a function. What about the second diagram? You have 1, -2, 1, -1, 2, 0, 3, 1, 4, 2. So just looking at the arrows, you can see that 1 used twice to represent two different ordered pairs. So since 1 was repeated, then we can consider this as not function. Okay, so the next one is a table, and it's like just seeing or looking at the value of the x elements. Okay, as long as there is no repeated value, you can consider that as a function. So for D and R, we have 1, 2, 3, 4, 5, and those are the elements of our x. So there is no repeated value, therefore that is a function. For x and y, you also have 0, 1, 2, 2, and 3. And if you can see, we use 2 twice to represent ordered pairs. Therefore, that is also not function. For another table, you have -4, -2, 0, -2, and -4. And as you can see, there are two values that represents -2 and -4. And therefore, we can consider this as not function. So always remember that our elements in your x or x values should not be repeated. Now, what about this one? Determine whether each of the following is a function or not. Click the letter of the correct answer. So, what do you think is the diagram? Is it a function or not function? So, if you answer that it is a function, you are correct. Next, what about this one? You have 2, 3, 2, 5, 4, 7, 6, 7, and 8, 9. So what do you think this diagram represents? Is it a function or not function? If your answer is not function, you are correct. This cannot be considered a function because 2 represents two different ordered pairs, which are 2 and 3, 2 and 5. Moving on, we also have here 2, 3, 4, 5, 6, 5, and we have 8, 7. So if you think that this is a function, you are correct. Next, we have here a set of ordered pairs: 1, 3, 2, 4, 3, 5, 4, 6, and 5, 7. Again, just take a look at our first element or the values of x. If there is a repeated value, meaning that is not a function. But if every value is unique, we can consider it as a function. So you have 1, 2, 3, 4, and 5. If your answer is function, you are correct. Moving on, we also have here 1, 3, 1, 4, 2, 5, 3, 6, and 4, 7. Look at the first element of each ordered pair. If there is a number being repeated, therefore it is not a function. But if everything or every element is unique, therefore it is a function. So in number 5, if your answer is not function, you are correct. Alright. This time, we are going to identify whether a graph is a function or not function by using a vertical line test. So we have here 4 different graphs. And for A, we can consider this as a function because if you are going to use a vertical line test, it will only touch the graph at every single point. And for B, we can consider this as a not function because if you are going to draw a vertical line test, the line will touch the graph at 2 points. So it is not a function. Now for letter C, what do you think is the graph? Is it a function or not function? If you answer function, you are correct. Because if you're going to draw a vertical line, it will touch the graph at a single point in any part. What about D? Is it a function or not function? If your answer is not function, you are correct. Because there are points that the vertical line will touches the graph at 2 points. So meaning to say, it is not a function. Now, let us now generalize our lesson for today. So when is a set of ordered pairs represent a function? A set of ordered pairs x and y represents a function if and only if no two distinct members have the same first element. So that's it. I hope that you learned a lot from our lesson for today and hope to see you soon for our next videos. Thank you so much. Bye.